Hello students, in this lecture we are going to discuss about reverse bias characteristics of a Zener diode. So already I have explained you about reverse bias characteristics. I hope you remember this presentation. So please look at the presentation. So here I am increasing the reverse voltage from 0 to 5, but nothing is happening until the voltage across the diode reaches 5 volt. 1 volt the current is 0, 2 volt current is 0, 3 volt current is 0, 4 volt current is 0. But the moment the voltage reaches 5 volt or the breakdown voltage VZ, the current starts increasing from 0 to infinity. So from the graph we came to know that this diode, it can conduct the current in both the direction. It means both the direction mean during forward bias and reverse bias. So it conducts the current in both the conditions, forward bias condition as well as the reverse bias condition. So this current has to be limited. Otherwise what will happen? It may damage your diode. That's why so we have connected a resistor in series with the Zener diode. But this is for an ideal case. In ideal case, the current is 0 till VZ, Zener breakdown voltage. But in practical case, there will be a small amount of current which is flowing through the Zener diode. That current is known as reverse saturation current. So this is your VZ. VZ is nothing but breakdown voltage. At VZ, Zener breakdown occurs because of high electric field. So the depletion layer will be vanished. So because of that absence of depletion layer, there will be a large amount of current flow through the Zener diode. It may damage your device. So that we have connected a series resistor with the Zener diode. So look at the scale. It is in milliampere. But in the previous case, it is in the order. In the PN junction diode, the reverse bias current is microampere. Now let us compare the characteristics of PN junction, VI characteristics of PN junction diode and Zener diode. Look at the characteristics. So during the forward bias condition, both the diodes are same. But what about the reverse bias condition? In reverse bias condition, the current flowing through the PN junction, it is in the order of microampere. But here it is in the order of milliampere. And this breakdown voltage may 50 volt, 100 volt, 150 volt. This may go up to 1000 volt. But here this Zener breakdown voltage, it may vary from 2, 3.3, 5 and up to 400. So this is Zener breakdown region. So this breakdown is mainly happening because of the avalanche effect. But here the breakdown is happening. The breakdown of depletion layer is happening because of the Zener effect. Zener effect now, due to the very high electric field in the depletion layer, the depletion region, your depletion layer is breakdown. So that is a Zener effect. Zener effect is mainly due to high electric field. Avalanche effect or avalanche breakdown is mainly due to the ionization process. And difference between PN junction diode and Zener diode. So normally it is a semiconductor diode which conducts only one direction. Because it reverse bias, the current is almost zero. But Zener diode, it conducts the current in both the direction. During forward bias direction and reverse bias direction, also it conducts the current. Thus this is symbol. And reverse current effect, it may damage the junction, means once the voltage reaches the breakdown voltage, your diode will be damaged. But here diode is not damaged. And doping level is low. Here the doping level is high. And breakdown is mainly occur at a very high voltage. But here breakdown is occurring at lower voltage. And it obeys Ohm's law in linear condition, but it doesn't obey the Ohm's law. And application, it is mainly used for rectification. It is mainly used for voltage stabilizer. So this is the data sheet of Zener diode. So here you can see the breakdown voltage. It varies from 3.3 to 100 volt. It depends upon the diode. And here you can see the reverse saturation current. And these are the maximum current that the diode can safely conduct in reverse bias. So please refer it. So in next lecture we will see the application of PN junction diode. Thank you.